Hello everyone, welcome along to our latest webinar here at Smart Cities World, the leading platform for sharing ideas to solve urban challenges. I'm Luke Antonio, Senior Editor here at Smart Cities World and your moderator for the next hour or so, as our associates for this session, Quorum, guide us through predictive traffic analytics and their impact on real-world urban mobility. As always, we have a couple of experts lined up to take us through today. So I'm going to introduce Jan Trudeau, Product Development Manager at Quorum, and also Joe Guthridge, Senior Product Manager at Dynamic Content at Here Technologies. Welcome along, guys. It's great to have you with us.
Well, thank you very much, Luke. So thank you very much for joining today. I'm sure people are coming and joining us everywhere across the world. So good morning, good afternoon, or good evening. So today we have a great topic to describe about. Again, thank you very much. Both Jan and Joe will be touching on really an interesting topic around urban mobility. So just before we dive into, I wanted to just talk about Quorum and Here delivering both this joint webinar. I mean, we, Quorum, have been a value-added reseller of Here Technologies, and we've been in this long-standing relationship for over 16 years, and it is going stronger as the year passes. You will learn today the breadth of expertise Quorum has built over all these years and how we help customers successfully adopt geospatial data and technology. This is achieved through our personalized data as a service offering, our extended team ability to build applications and or dashboards, or with our advanced geospatial data modeling and integration support. So today we are going to emphasize on ways detailed historical traffic data impacts us and our businesses. We will give you examples on how mobility data can help predict demand and how it is used in transportation model. We will also touch on why we think AADT is outdated, and we will share a customer case study and how they are using this detailed historical traffic data into their analysis. But firstly, this shouldn't be of any surprise to anyone, but per Forrester, the golden age of geospatial analytics has arrived. What it truly means is that our mobile or smart devices that we're using on a regular basis, along with driving our cars with these intelligent navigation system embedded into them, all generate tons of location data points. Hey, we're talking of over 46 billion devices that are connected to the grid, generating location data. That is a big and a real big data challenge for many organizations to deal with, and how to derive this valuable insights from this type of data. So hopefully on our registration page, you've seen that we've touched on the growing challenge of urban mobility with, for example, the growing population. By the way, I don't know if you've heard this, but in November, the UN officially said that Earth population has now reached 8 billion people. Wow. Well, this adds extra pressure to our existing road networks, many of them which are often outdated. So commuters using public transits are also impacted as there is an increase in road congestions. There's unexpected events such as accidents, there's road constructions, or any other types of events that happens. And then recently with the pandemic, there was a demographic change where people moved away from city centers to more rural areas. Traffic congestions impacts the quality of life of citizens. It impacts the mood and the health, but also the environment where more population is generated, as well as the economy. And so old methodologies of collection like AADT, which we will touch on shortly, doesn't provide you with this sudden shift in near real time. So taken as a whole, this is where only the most recent vehicular traffic data will aid geospatial models and support more accurate location-based analytics models, be it for site selection, identifying new warehouses, or even optimizing public transit routes. Today, I have the pleasure to have with us Joe Guthridge. He's product manager of Here Technologies, Dynamic Content. He is a veteran in his field of expertise. Joe, thank you for being with me today. I appreciate you. And could you please talk on your recent analysis regarding the impact of the pandemic and remote work?
Happy to. Yeah, when we first started looking at the effects of the pandemic through the lens of our traffic services and products and data that we collect, it was no surprise, right? Traffic congestion evaporated in the first months of the pandemic. That was a straightforward conclusion and observation. But much more interesting has been the shape of the recovery. In some places, traffic congestion is by now back to normal, and in other places it hasn't rematerialized at all. So, and you start to think, why is this? Certainly it's clear that office workers are still doing a lot of remote work. So there's not necessarily the same congestion patterns in central business districts, for example, although a lot of them are seeing congestion happen again quite quickly. And this has a little bit to do also with the gradual increase of public transportation as the public transportation authorities ramp their services back up to meet demand, and sort of the bumps in the road having to do with that. So that's about central cities, but also well, another thing that happened in the pandemic is the strong growth of last mile delivery, whether that's Amazon or Instacart or Grubhub or whatever your favorite delivery service is. These services have also changed the texture of residential congestion, and they've amplified the need for careful transportation planning, not just for these last mile services, but also for public transportation.
Well, thanks, Joe. This brings us to expand in 3 specific use cases where we believe granular insights of traffic and road attributes is critical. Like Joe referenced, last mile delivery, it's all about optimizing your fleet management. Everybody's been using e-commerce, increasing local deliveries. So what you're buying online, you want that to be delivered on time at the right location. And this type of traffic and road attributes can really help optimize this. Another important is from a retail and real estate site analysis standpoint. The data is critical as it provides key insights on potential sales volume or understanding if new locations will become a popular hotspot or understanding the traffic flow trends. It also helped the closure or relocation of less performing stores or locations. Finally, as we will touch on in a few minutes, optimizing public transit efficiency is another key important applicability of the use of detailed traffic and road attributes. An example on how we help customers at Corem understand the true correlation in using traffic analytics data would be through building dashboards similar to what you are seeing on screen. In this example, we are using traffic analytics data to see convenience store location potential sales impact. The size of the circles and points on the map on the left indicates the relative traffic volume. On the right, the bar charts indicates the absolute traffic counts per days of the week. So we see quickly how traffic is fluctuating from one brand to another over a trade area from a daily basis. This provides competitive insights where you can see a store where it's mostly prone to be more performant than others, which then can help you take and make those factual decisions. This data is so granular that you could break this down by the hour, where in the specific examples, we're seeing high traffic on Sundays around noon. We can derive lots of interesting patterns and even models from using this data. The detailed historical data provides you with better insights, for instance, on the side of the streets of the traffic, difference between trucks and cars, with a panoply of other options. Businesses, to gain some level of insights, previously used for these analysis, the AADT averages. Now let's expand on why do we believe that the annual average daily traffic is no longer a standard. So many of you know that AADT is based on samples of data collected on specific road segments, which, by the way, not all of the road segments gets collected. So I see you nod there, Joe, in agreement. this translates into broad estimates. The collection of AADT is done in either by hiring someone and sending that person to observe and record traffic, or using automated traffic counters. These are often fixed for a period between 2 to 14 days. You know those black pneumatic tubes that you see across the roads? Well, those are those automated traffic counters. So let's not forget that AADT is still a standard used by many, if not all, transportation authorities to forecast maintenance needs and expenditures. Now, what if we were to say you don't have to settle with the average anymore? That is where we think the future is in using detailed historical traffic, or you'll hear us refer to DHT, which is directly derived from probe data, offering accurate granular data in time, and it depicts a true representation of what is going on. Now, Joe, I've been talking a lot now. From your many years of experience, have transportation agencies changed their way of optimizing maintenance and planning needs, as well as their cost?
Sure they have. I like the way you're styling this detailed historical traffic, or DHT, in this context, because what it shows is that adoption of this data overall is a process for both for transportation agencies and as well for other kinds of users. I would say that the last 5 to 7 years have finally seen the acceptance of large data sets made from probe data. We'll talk more about what that is coming up. But the mind shift for everyone is in letting go of something really tangible, like a car tire rolling over a rubber tube and making a counter tick on the side of the road, and embracing something that's just statistical in nature. It's a sample of movement, so it has outliers, it has gaps and different kinds of anomalies. Now, all of those require a certain kind of treatment, mostly from statistical theory. But once you're over that hump and you know how to deal with it, there's so many advantages to probe-derived data products that it's the right way to move forward. It has so many advantages.
Well, that's great. Thank you, Joe. So detailed historical traffic data has also been around for quite some time and was mostly used by public sector organizations, including public transit authorities. And only recently, retail and our other organizations started to find deep value in it. Since the data is gathered from probes on the roads and it is provided for every road segment in a geographical area, offering many options and attributes, Joe, can you explain to us in details how your team is dealing with dynamic content coming from those billions of devices, and explain the many options available with this data? Sure.
When I've talked about probe data, and it's sort of the fundamental source of all of this. And what we're talking about here is a probe represents the position of an actual vehicle on the road, gathered from an in-car navigation system, a telematics application, or a smartphone in the car, many different sources. This kind of data is also called floating car data or waypoint data, but it's all the same thing. We talk about it as probe data. So it depicts a factual subset of all the vehicles on the road in an area. And it allows for accurate comparisons of different locations according to geography. Now, depending on the provider and the region, probes can account for anywhere from 5% to 40% of the actual vehicles on the road. And this number is continually increasing as more and more vehicles from manufacturers are truly connected all or most of the time. But we make this daily historical traffic data from that. When we make it available with a 2 to 3 day delay in 5-minute intervals, although mostly that's a lot of data, and so most use cases deal with it at the hourly level every day for each road segment, and we keep this data for at least 5 years.
Well, that's great. Can you also expand on the importance of the difference between cars and trucks? And as well, I mean, we all heard this year EV is being a hot topic. I mean, can you expand also if here is looking to expand in that field as well?
Yeah, you mentioned this earlier when we talked about it's not just about looking at congestion and road improvements. There's a lot of other use cases here. And we think about the difference between car traffic and truck traffic. Well, at the bottom, cars and trucks both have to sit in traffic if there's traffic. But the other piece about trucks is that many trucks are carrying goods that and moving goods around, and that forms sort of the basis of an economy. So when we want to look specifically at truck data, a lot of the time what we're talking about is, you know, keeping the economy of a region going, and that has a whole different set of drivers as well as solution sets to make an economy well lubricated and keep the transportation of goods working well. EVs, you also mentioned, you know, they're becoming a much more important thing. And so, for example, many municipalities are grappling with the question of how many EV charging stations do I need, and where should they be? So, looking again at the way EVs drive around the roads, it obviously informs that as well.
That's great. I think you have this short video you want to introduce to us.
Yeah, that's right. I was going to talk about this from just make it a little bit more practical. We were talking about probe data, and this is just a little visualization of probe data. What you're seeing on the screen is an overhead view of a border crossing between the United States and Mexico, and each blue dot there represents a vehicle. So as Jan plays this sort of an hour by hour picture over a couple of days, what you can see is sometimes there are a lot of vehicles and sometimes there aren't very many vehicles. And that's because this border is closed overnight and significant parts of the day too, depending on what's going on. So, you know, that's an observation, the first observation you make here, but when you get more into the details here, you can also see cases where, you know, vehicles are lining up on either side of the border just before it opens so that they can get across early. And, you know, finally, then you can dig further into this analysis and see, you know, how long it takes vehicles to cross the border, and talk about, you know, impact on economy and commercial aspects. That's a prime one right there, right? So essentially, this is a picture of what probe data looks like. And I think if you roll the slide down next, Jan, we have a different visualization of probe data, which is a picture there on the right-hand side. This is a map, and it has a different representation of probes. It's sort of a composite over, I think, the course of an entire day, where each vehicle's position or probe point is represented by a little arrow. And it illustrates the fact that generally probe points come from vehicles with a speed and a direction in addition to a position on the map. And so the speed is coded by color here, and that the arrow points in the direction. The thing about this is that when we went from the previous slide to this one, there's a lot more probes represented here. And while probe data is good for looking at traffic behavior in small areas, when you start to get huge quantities of it, you can see this is only one day's worth in a particular place. And by the way, you might want to see if you can ask yourself where exactly in the world this is. I'll expose that a little bit later. But the big value here is when you have a lot of probe data. You can start to paint the picture for much more global areas, like states or even provinces or even countries. At the large scale like this, statistics, you have to implement your statistics using machine learning models, because there is just so much data here. We've talked about here processes billions of probe points in every day. So the scale of this means that you can't have people doing the analysis anymore. You have to trust machines to do it. And machine learning is a really good tool for this, particularly at identifying trends out of this data. Of course, you can use this data to do before and after analysis. Maybe you make a change in the road network or in your transportation policies, or you can search for hotspots as well, think places in the road network that cause trouble or need help. But trend analysis is a really big use for machine learning on this kind of data.
Well, Joe, this is impressive. I mean, by curiosity, I mean, what's the impact for a year of having to deal with this large amount of data on your backend systems?
Right. Well, here Technologies has for several years been one of AWS's top customers. And it's because we have to deploy so many computing resources to deal with this onslaught of data. And one of the implications of that is that you only want one person doing this kind of processing. There's no reason to spend all the money and computing cycles taking this raw data and turning it into information. So here does that because we've been doing it for almost 2 decades, and we know how to do it very efficiently, and we do it for a large range of markets. But that's the value that we bring to the table, is the ability to take this huge amount of data and turn it into information, which is also quite large bit of information, but at least it's an order of magnitude smaller. Oh, I was also going to say about this chart. If you happen to guess that this is the traffic circle around the Arc de Triomphe in Paris, then you would be right. That's what's going on here.
That's absolutely true.
Yes. Right. So let's take a quick poll, if we could. We're curious, just to right off the bat here, whether the organization that you're working in today, are they using historical traffic data? Do you use this kind of data to make better informed decisions? Your choices are yes and no. And since you're on this webinar, I would assume that the no has a tag on of I am interested to learn more. So take a minute and cast your vote here.
We'll give it another 10 seconds. There's a good number of entries coming in, so we'll share the results later.
All right, I think the polls are in. Let's move on. So today we are going to be talking about one of our case study, a customer case study. Today I'm proud to present EXO. Our client EXO is a public transit authority in operation since June 1st, 2017. It oversees really the commuter rail services, as well as the North and South Shores buses and paratransit services, basically for disabled and mobility impaired persons. They are a major player in intelligent public transportation here in the province of Quebec. EXO's territory comprises those of the Communauté Métropolitaine de Montréal, which is approximately 82 municipalities with more than 4.1 million inhabitants. Just in 2019, they've handled over 43 million trips, and that is a lot. Now, if we get into kind of the challenges, I mean, again, going back, EXO's top priority is to maintain daily commutes that are fast, reliable, integrated, and pleasant. Now, an indispensable tool for its research, data and analysis and modeling department, the traffic data EXO uses is a starting point for its strategic projects, as well as technical orientation and operational initiatives in its network. EXO has been obtaining traffic data through COREM for a number of years now. In 2018, the publisher of this data made major changes to its rate structure. As soon as the new structure was published, COREM estimated the financial impact of its clients, including EXO's, and advised accordingly. COREM's proactive approach cushioned the blow and gave the opportunity to reassess their renewal budget and explore alternative solutions within COREM's diversified portfolio of data. So for EXO, the data publisher's modified rate structure would have meant a significant increase in annual usage costs. Although it was pricing changes that prompted EXO's evaluation of other data products, EXO also wanted to be able to better optimize its use of data for the benefit of its services on the road network. EXO did not have access to historical data, which means that it had to specify the exact road segments it wished to study, by querying the publisher's database on a regular basis, and then wait for the data to accumulate over time, being able to analyze it. I mean, with one-off analysis like these, it was impossible to obtain an overview of the traffic, and it was certainly not possible to obtain information by sectors. So with the goal of improving the experience of public transit users in mind, it was essential for EXO to have data that would give them a better picture of the congestions. so that it could properly evaluate travel times and its bus and paratransit routes. So again, with working directly with COREM's in-depth knowledge of existing traffic data and of their client situation, the experts at COREM were capable of immediately proposing an alternative that corresponded to EXO's needs while accelerating its response time to requests. So after demonstrating the alternative data, EXO was able to validate that the recommended solution met their needs by gaining access to the data in order to perform tests. The data in this instance from HERE Technologies and their product, Traffic Analytics, or as we referred it to the DHT, was chosen. With this, EXO was able to boost its analysis of performance and reduce its costs. As it only needed some of the air traffic data, COREM also performed a spatial extraction of the desired region. This personalized data as a service helps reduce file size, reducing downloading and processing time, and readies the data for faster analysis. And from a legal point of view, COREM team ensured that the terms and conditions allowed for every use cases and scenarios EXO might require, which is really important. Now, when I think we've depicted pretty nicely today that working with probe data, which HERE does a beautiful job at, and providing the detailed traffic data, it is big data in the end. So since Quebec's road network is divided into millions of directional links, HERE can provide from millions up to billions of new rows or record per month. All this depends on the options you've chosen, whether it's 60 minutes or down to the 5 minutes epochs, thus resulting in a monthly volume growth of more than 1 terabyte. It goes without saying that with such data volumes, analyzing traffic congestion is not a walk in the park. So EXO initially started off using the 60-minute epochs on their own servers, where it took roughly 48 hours to update the data. Let's not forget EXO's need to find faster or most optimal routes between millions of origin and destination points, which is a primary use case for EXO's analysis. It used to take weeks to months. Now, EXO, having access to the 5 minutes epochs with COREM's data license, but wasn't necessarily leveraging the granular and the level of precision of these 5 minutes epochs due to processing limitation. EXO looked toward a modern data cloud platform. And today, what used to take weeks to months of processing is now questions of hours and days. So as we just reviewed the EXO case study, DHT data brings tremendous value in the urban mobility, but aside the optimization of transit schedule, Joe, could you please provide some insights on where does predictive versus analytics apply in public sector specific use cases?
The public sector applications for traffic data in general take two different forms, operational and planning. That's the way we traditionally talk about it. Operational data is typically mostly about real-time data, so monitoring traffic, seeing what's going wrong, deciding how to manage situations and respond to them. But even some of the operational scenarios which we support with our real-time traffic data, even some of them can also use historical data. And you think about the power that a person in a traffic management center can have at his fingertips when he sees an accident on a particular stretch of road, and he can call up and say, all right, when there's been an accident before on this stretch of road, how long has it taken to clear, and how bad has the traffic been affected? And so with that information, you can plan an effective in-the-moment operational response. But a lot of the cases for detailed historical traffic are in the planning area. And you think about cases like construction. Obviously, if you decide to improve the road network, you want to make sure that once you've done that construction project, it actually improved people's experience. And you can certainly do that with this kind of data. You can also look for trends. I've already talked about as well economic efficiency or economic impacts to traffic of goods through the road network. And then sort of traffic travel demand as well is an important piece of origin and destination analysis.
Well, that's great. Thank you, Joe. Well, this brings us to our poll question number 2. Is your organization impacted by trends in mobility today? In which functions will this affect you? And we have 4 possible answers: in the planning, the operation side, in the strategical side, or no, not at all. We'll give you a couple of seconds to answer. All right, thank you very much for all your answers. So to summarize, with Corem personalized data as a service, we ultimately help customers save time and energy by having access to multiple data vendors in one place. When working with Corem, you get the data you need in the format that addresses your business objectives. So we provide, from a data sourcing standpoint, advices on the best suited data for you, the licensing compliance support, better understanding of pricing models, integration of multi-vendor data sets. Now, if we move into from a data processing standpoint, you will get the expertise and manpower so you can use your time more efficiently to focus on value-added tasks while we reduce time to value. Corem has teams of qualified workforce with leveraging a breadth of advanced and powerful tools offering many data processing options. Once the data is processed, we offer various methods of delivery that will serve your needs. Like we have done with EXO, we aggregated the data every month and then delivered to automatically process into their modern data cloud platform. With other customers, we provide automated daily deliveries, something which here technologies directly doesn't necessarily offer. That is why working with value-added resellers and experts poses advantages. Now, Joe, tell me, the air traffic analytics data was originally built for the public sector. Can you speak to the value that Corem is bringing to you and air technology as a whole?
Sure. Yeah, we've spent years working with our public sector markets, and we know how hard that is to break it. It's a particularly sort of change-averse market. It's hard to break into. So as we started to see that this data is very valuable in other markets for other use cases, it was natural for us to turn to a partner like Corem, because not only are they good at handling the quantity of data that we deliver, they understand big data handling as well and turning that into information. But they also have deep knowledge about these problems in other markets and how to approach them. So Corem is a great partner to make this data useful for a much broader range of customers.
That's awesome. It's a great partnership, Joe.
Yeah, thank you. I think so.
So as you can see, choosing between annual average daily traffic and detailed historical traffic will depend on your business drivers. But organizations today tend to choose detailed historical traffic because its capabilities to address more businesses' needs and cover almost all of the AADT use cases. Once that decision is made, the next step is selecting the right data provider, as there are multiple ones, and as described previously, there are many aspects to consider in choosing the right one. Corem, as the only one-stop shop in North America, can help you. We help our clients in managing their risks with our 5 main business pillars or offerings, which is through strategic consulting, contract advisory, the data and analytics, the system integration, to finally fully managed services. Ultimately, we make sure our clients are successful in adopting geospatial complex data while managing the risk. Now, if we go back quickly to the EXO case study, well, they have benefited from, in this instance, from our contract and management advisory services, along with our data and analytics capabilities. So with Corem's extensive experience with traffic data and its business value for its customers, not only do we understand applicability of this data into urban mobility use cases, but also in other non-traditional segments such as banking, finance, in the insurance space, the retail, the real estate. So this expertise allows us to help customers select the right options and seamlessly integrate the data into their businesses or analytical or even modeling processes. The if you are interested in what you've heard today, our suggestion as a next step is to engage with COREM in a traffic analytics pilot project. If you wonder what this is, it's basically a multi-step process. It's a collaborative process between COREM and our clients, in which we work iteratively toward the best possible outcome and to employ best practices. It will take us from understanding your expected business outcome through ideation, through scope of works, and development of a pilot. So today, we thank you for attending. Both Joe and I really appreciate the time you've taken to jump on this webinar. We hope you found value in what was presented. We will now head into a Q&A session, but before we do, let's review the poll results together.
Excellent. Thanks very much, both. Thanks a lot for your insights during the presentation there. And it's really fascinating to see some of the pictures of what this data looks like, and also what can be done as well to improve cities' mobility networks. Obviously, we did have a couple in the audience correctly identify the Arc de Triomphe there in that picture, and I don't think you could have picked a much more extreme example anywhere in Europe of quite what that data looks like. But it's fascinating to see it in that way, and just see, I suppose, the sheer mass of it, really. But like you said, Jan, let's move into the poll results. So the first thing that we asked was around historical traffic data and whether the organisations of those of our audience members are currently using historical traffic data to make better informed decisions. 53% have said yes, 47% have said no. So it's basically a 50-50 split there. Is that kind of in line with what you might have expected to see, or seeing more than half of respondents say yes, is that more or less encouraging in terms of the progress they're making within their organizations and cities?
It's actually really encouraging to see there's a 50-50 split. Joe, I would appreciate your input on this, because I feel it actually shows that there's a lot of people still maybe want to discover this data, and then we will for sure reach out to these person interested in to learn more of what they could do with this type of data. But knowing that then the other almost 50% are using this data is also really great to hear. As we depicted today, AADT is maybe something the older standard ways of doing stuff, and then now you need to look into getting that really live representation of what's happening on the road network.
Yeah, I think the fact that half of our audience is already using this data in some form indicates that the adoption of this data and the profusion of it throughout all of the use cases for enterprises is a process, and it's still happening, and it's still increasing.
That's great.
Yeah, absolutely. And obviously the second question is around mobility trends. We love mobility trends here at Smart Cities World, so this is a great question and good to get people's insight direct as well. So is your organisation impacted by trends in mobility today, and in which functions would this affect you? So the majority in strategy, followed very closely by those in planning, then operations, and 17% saying not at all. So I guess congratulations to you guys. But I'd be really interesting to kind of get your take on how your work kind of feeds into some of those areas, especially planning, I think, and then how that filters down into helping organizations to address their strategy as well.
Yeah, well, I found you're talking about planning. Planning is an interesting one, as we've seen with the case study with EXO. It's all about planning, making sure that you optimize your routes and your schedules, and delivering that high quality service to your end customers. But there was also the strategy one, which is also something that we've found that COREM is really outside of the traditional public sector side, is you have an organization wanting to have access to this data in order to take factual strategic decisions based on that type of data. The insight you can actually gain from that is really valuable. And this is, again, is how we help customers basically find a quick return on investments by showing them the value it brings to them. Joe, I would like your take on that as well.
Yeah, sure. I think people who plan are used to using data, or more used to using data, but the people that strategize I think it's sort of a trend, a modern trend, that people setting strategy can still be informed a lot by data. And it's just the case that they usually need a lot more data behind the information they see.
Sure. We have some good questions that have come in over the last 40 minutes or so, and plenty of time to still get your questions in as well if you're holding on to something in there in the audience. So send those questions in and we'll get through as many as we can. I'll come to this the very first one that came in fact. And Joe, I see you've marked this as something you'd like to speak to in how you differentiate between cars and trucks and that kind of incoming data.
Sure. There are two ways. First of all, typically for a large portion of probe data, it's generated by a system that's embedded in the vehicle. So the system that sends this information knows that it's in a truck or that it's in a car and can indicate that as a part of the attribute of the probe data stream coming from the car. So some probe data sources can say I'm a truck or I'm a car, or I'm a two-wheeler, or even I'm a bicycle. That's a little bit less clear, because when you start thinking about bicycles and two-wheelers, a lot of the time the probe data is coming from a smartphone app, and all we know is it's a part of a smartphone. It's coming from a smartphone, and you don't know what's moving that smartphone around. So in that case, you use the second kind of analysis, and that is sort of taking a stream of probe data from a single device and categorizing it based on the characteristics of the movement. Like, if this is going 60 miles an hour, then it's probably not a bicycle or a two-wheeler in that case. And you can also look at sort of turn radius and other characteristics. So essentially, the answer to this is you can either get it directly from the vehicle, or you can do some analysis, typically by machine learning, on the stream afterwards to find out what kind of vehicle. And that can apply a bit to EVs too, although EVs, of course, look a lot like other cars and soon trucks as well. For them, you can, the pre-identification case is the most important. Although if you see a vehicle spending a lot of time at what you know is a vehicle charging station, you can pretty much guess that's an EV. Yeah,
that makes perfect sense. Let's take a look further down the list. Like you said, that was a follow-up question we had, was around obviously then also differentiating around EVs and other various different vehicle types. I suppose it's a challenge that's going to keep coming up, because road networks are being used for more diverse purposes now than ever, really. So it's going to be a really important thing for authorities to really keep on top of. Actually, with that in mind, there's a good follow-up question here as well around a similar kind of thing, in that just asking whether you would be able to measure and provide information for any other form of transportation, for example, cyclists, maybe micromobility, as these forms of transport and more active transportation methods are increasingly encouraged by local authorities.
Right. Yeah. I honestly, I kind of intended to address that in what I said previously. Certainly, it's possible to do for cyclists, even for pedestrians, and these are coming fields. We don't do it today because the market is still sort of developing, and just like anything else, it'll cost a lot of money to do that kind of analysis, and we need to be in the market yet. So that's an area that we're looking to push forward into the next couple of years.
Excellent. Another question, which Jan, I'd like to come to you on, is around excuse me, it's around the kind of main situations where the information is being applied. Obviously, we have the EXO case study. I would be interested to know whether that's something that's kind of typical in terms of incoming inquiries from the market to you, and what else you're kind of seeing in terms of the challenges that people are facing.
Yeah, thank you, Luke. I mean, yes, these are typical requests that we get. And like I was explaining, we also, in the non-traditional kind of public sector segments, we get a lot of customers kind of interested in understanding the mobility movement, the patterns and trends around the various locations of their stores, or it could be, so this is really, we've built basically the correlation directly to the performance, as we've kind of explained today. We've made some mention of this, which then allows organization to better take decisions with more informed kind of data that comes directly from the DHT data from the HERE technologies, as well as what we're seeing in is really the way of us processing the data. So we've touched on the data processing aspects, which is something complex, and not all organizations out there have that capability. So we can support organization as well in delivering in different manners, being raw data or aggregated data to specific locations that the various customers' use cases will need the data delivered. And so we've developed over the past years, basically various kind of ways of answering and supporting organizations out there. But all that ties back to the business cases and the clients' kind of needs in order to solve pain points that they're looking answers to.
Fantastic. One of the other things that we wanted to kind of cover off is roughly kind of how long it takes to implement this DHT data and actually, make it operationally useful then for transport authorities and different operators, whether those are public transport, whether those are in a different sector of the market like deliveries, and whether there's any difference there in that implementation between different sectors.
Well, actually, it goes back, I think, to what I just kind of touched on. It really depends on the actual business needs. I mean, our way of working with customers is getting engaged with them so that we can fully understand the challenges and make the right recommendations. I mean, we've again encountered all these many different use cases. Some organizations have the teams in place to process raw data or work with this kind of big data, which is something that you'll need to factor as a business. But our most popular offering, I would say, that clients are using from Carem is really aggregated services, or kind of what I referred to about the personalized data as a service offering. I mean, Carem basically prepares the data into that more digestible format and then deliver what is needed to the various organizations. Another option is really having Carem apply its data normalization models that we've built. And why we've built this is because it removes the bumps into probe counts that occurs on a regular basis. Again, I think Joe touched on this, but the detailed historical traffic data is a derived product from the probe data. So you will get these kind of fluctuation into the actual data. And so you need to factor in that type of normalization. And we did this, we've built this, we're offering this to our customers. So they don't have to rethink and rebuild all of this model on their own. I mean, this provides really the utmost value to our customers.
Yeah, for sure. And obviously data is right at the heart of all of this, and it's right at the heart of so many kind of new business cases and business models in across the whole city landscape really at the moment, which naturally means that eventually the question all has to come back to data security and data privacy, because it's just such a critical element to be able to ensure. So obviously in Europe we have GDPR, so how do you ensure that probe data is remaining private? And you mentioned aggregation as probably as part of that, but love to kind of dig into that a little more deeply.
Yeah, you're right. The short answer is aggregation, but so at HERE, we may get vehicle probe data. Anyone we get that from, we are clear that it has first of all been given permission to collect, and second of all, the data that we get doesn't contain any personally identifiable information. Here, as a global company, has its own privacy policy, which is a superset of GDPR and the California regulations and other regulations around the world, so that we can operate in one form across the globe. So it's certainly the case that once we hand any data outside of here, there is no personally identifiable information anywhere inside it. Yeah. And so when that goes to CAREM, we're clean already.
Yep, exactly. And I will add to this, Joe, that CAREM is also ISO 27001 certified. Yeah. I mean, has a value-added geospatial solution reseller, and as well as a system integrator. Achieving that certification became really important to demonstrate the compliance to the highest security standards. And CAREM really believed it was necessary to formalize its commitment to its customers in terms of data security, confidentiality, accessibility, and as well as integrity. And like you say, Luke, everybody's talking, it's a hot topic, GDPR everywhere. So for us, having that certification makes us proud, and also secures our customers working with us.
Absolutely. I think one word you mentioned there, integrity, is absolutely critical. I think that will really resonate with the audience, knowing that they can. It's important to know that you can count on that as a building block, really, to kind of build from. Another question that we've had kind of sent in is around centralization, and if you're an organization that has, for example, hundreds of locations around the world, so obviously applies less to kind of public transit and that type of business, but plenty of others in the kind of goods delivery space, especially, if you have all of those different locations spread across the world, is there a way you can manage those centrally and efficiently? Efficiency is right at the heart of this conversation, and absolutely critical to be able to, make sure you have it.
Oh, certainly, yeah. Well, to start, here is a global company. We have this detailed historical traffic data. Our traffic analytics product is available in 57 countries around the world, and we plan to expand that. That data is, we actually produce live traffic data there, and also the historical data. And this is where CAREM comes into play with their personalized data as a service offering too.
Yeah, and that is absolutely on point, Joe. I think CAREM's unique value in offering through its personalized data as a service, as well as what we've touched on today is this 5 business pillars, allows us to deliver exactly what the customer is looking for. And for instance, we have identified 8 different kind of pilot projects, types, I would say, depending on the customer's needs. And so this is why we're inviting people to get in touch with CAREM so that we can support them, understand their needs, but offering them also the right pilot project for what they're trying to achieve.
For sure. I think that feels like quite a neat place to kind of wrap up.
Yep.
We always encourage our audience to get in touch with the people who present and speak during these webinars, and please do reach out today, keep this conversation going, because it's such an important time for this space and for this sector. And again, coming back to the point around efficiency, it's so important, especially when you consider the kind of, I suppose it's really potentially transformative effect that more efficient urban mobility and urban mobility networks can have in a wider city context as well. So when you consider congestion, pollution, air quality, and their links then to overall livability, it's much broader than the conversation that we've had here today, and really plays into so many other different parts of the kind of city ecosystem. So it's a really interesting time to be having this kind of discussion. So thank you both for your presentation, for your insights during the Q&A as well. And as I say, do get in touch. If we didn't get to your questions, then feel free to reach out, I'm sure, and have them answered direct. I'm sure these guys would be more than happy to do so. But for now, just thank you once again for joining us. Thanks for those of you at home or in the office, wherever you might be, for watching live or on demand. And thanks as well to Carem for their support of this session. Thank you very much, and I'm sure we'll see you next time.
Great. Thank you very much.
Cheers all.
Thank you, Joe.